You are welcome to the physics class again today. You are welcome to the physics class. And today, as I promised, we are going to have a look at what we call lever. Lever, Lever, is on the board. Lever. Lever. It's not this one. It's not the lever. It's not this one. This was the lever. Lever. Okay. Then let's look at what lever is. A lever is just one of the simplest simple machine. So it has, this is the lever example. I want to use this to demonstrate the meaning of lever. So it has a rigid bar, a rigid, strong bar, so that is supported at the fulcrum. Fulcrum here is the pivot where it can rotate. It has a point where it can rotate. So now we can apply effort here. And use this to shift a load. If you can put a load here, I can use this thing to shift it to any direction I want it to go. I can shift it to any place I want it to go. And very easy to do. Like if it's a very big, very heavy load, with this particular place, the fulcrum or the pivot, where this bar, where this is very strong bar is, I can use this to shift any heavy load to any direction I want it to go. So a lever can also work in what we call the principle of moment. Here, from here to here is distance moved by the effort. This is where my effort is. While from here to here is distance moved by the load. The distance moved by the load here. From the center here, the fulcrum, to here is distance moved by the load, where this is the load itself. And then here, where my hand is where the effort is. Here is the effort. Here is the fulcrum or the pivot. Here is the load. Now, this is a simple machine. Even here, even the scissors has it. The scissors has the effort point where I can apply my effort, and it has a place that rotates. Here is the fulcrum, or the pivot. So here, example, let me use this one for example. Here, this is where my hand was before. This is where the load is. Here, the load is here. Here, from here to here is my effort distance. Distance moved by the effort. While from here to here is distance moved by the load. Well, this is the load. This is the load. So now, from what I told you, that the mechanical advantage is equals to velocity ratio here, it means that if I multiply the effort, this is the effort is here. This is where the effort, this is where the load is. Load is here. If I multiply the effort, or if I say the load over effort, which is this one, load over effort is equals to distance moved by the load over distance moved by the effort over distance moved by the load. That is to say that mechanical advantage is equals to velocity ratio. So in these scissors here, we have the fulcrum here. Here is the moving part. This is the fulcrum. Here is my fulcrum here. The fulcrum is here. Fulcrum. Or the pivot. Okay. Even this one here has the effort side here. From here to here is the effort. And here, this is a nail. If I put it here now, here, Here, this is the load. This is the load. Here is the effort. And here is the rotating part. Here is rotating. Here, this is rotating part now. If I put it here, see, rotating part. That is it. So it has the fulcrum, it has the effort, it has the load. Even this one here, it has part that is rotating here. Here is the rotating part. Here I put my effort here. Here the effort. Then here, this place here is where the load is. Here rotates. Here is the fulcrum. Here is rotating. Okay. So lever, we have the effort, where the effort is applied, and it's where the load, the resistance, where the resistance is overcome, and also we have the fulcrum. So we have types of lever. So here we classify lever 1 into first order lever, second order lever, and third order lever. What is the first order lever? First order lever is found where the fulcrum, the part that rotates, is between the effort and the load. So this principle of moment is a type of the first order lever. Why? See, first order lever. Because here, at this place here, this is my effort side, and this here is the load side. Now here is the center. So as far as the fulcrum is between the effort side and load side, this is called first order lever, a classification of lever. So scissors, plier, even plier is also among those that are under first order lever. What is first order lever? First order lever is order of lever whereby the fulcrum is between the effort and the load. We see it in scissors, we see it in plier, we also see it in the principle of moment. Now, second order lever. Second order lever is seen here. For example, here, look at the board here. Example here, we see it here. This is like, let's assume that this is a wheelbarrow. Okay, now, where do you think is the rotating part? Which part rotates here now? It is the tire that rotates. Here, rotates. Now, where do you put your hand? Where is the effort? This is the effort. What of the load? You put the load here. The load you want to carry to market, this is why you put it. So this is a machine. Now, this is the rotating part. The second order lever is where the load is between the fulcrum and the effort. Where the load is now between the fulcrum and the effort, we call it second order lever. Unlike this one here, the rotating part of this one here is at the middle of the effort and the load. So we call this one first order lever. This one here, where the rotating part now, the fulcrum is now, the fulcrum here, the load that you are carrying is between the fulcrum and the effort, is called second order lever. So a wheelbarrow is second order lever. Now let's go to third order lever. Third order lever is where the effort now, the effort comes between the load and the fulcrum. Do you know that your hand, this hand is a simple machine? It's a simple machine. Which part rotates now? In your hands, here it rotates. This place is the fulcrum here. Here is the fulcrum. Where is the effort applied? Effort comes from the muscle here. This is where the muscle come. What of the load? This is the load. See, we carry it here. So now you can see that the effort here is between the fulcrum and the load. So your hand is also a simple machine. Your hand is a simple machine because the way this one is, this is how your hand is too. Why? This place is where you carry the load. Here, this place rotates, like this place is rotating. This is where the effort is supplied, the muscle. The muscle is supplied here. So the human being, the human arm is under third order lever. Third order lever. Do you agree that your hand is a machine? It works like a machine. It's a simple machine. Here is the load. Here is the fulcrum. Here is the fulcrum. And here is the effort. So the effort is between the fulcrum and the load. Third order lever. That is how it is. What have we done today? What we have done today is that we have defined lever. What is a lever? A lever is a simple machine that has a stiff bar, very strong, a strong bar. It has a strong bar. At one point, the effort is applied. At one point, there's a rotation, there's a fulcrum where it rotates. The other part is where the load is applied. What again? We have also learned that lever can be classified into three major parts. One is what? The one we call first order lever. First order lever is where the rotating part is between the effort and the load. Second order lever is where the load is between the fulcrum and the effort. What of third order lever? Where the effort is between the fulcrum and the load. In next class, we'll discuss other types of machine to help us calculate the velocity ratio of such machines. Thank you very much. Follow and be happy in physics. Thanks.